Hello and welcome to this first of a series of webinars from AI Sprint, a European Horizon 2020 project. Today our webinar features the EU perspectives on the future of AI and edge computing. A warm welcome to all of our participants, which we know are coming from over 30 countries around the world, many from Europe, but also internationally. So a warm welcome to all of our participants. And I will be presenting to you this morning all of our panelists. We're going to start with some viewpoints from the AI Sprint project, and I will be first introducing Danilo Ardegno, who is Associate Professor at the Politecnico di Milano and Scientific Coordinator of AI Sprint. His research focuses on performance modeling and cloud and fog system resource management, and he will be giving us an overview of AI applications in edge and cloud environments in the context of AI Sprint. We also have some market data, which is very interesting. So my pleasure is to pass the floor to Danilo. Thank you, Danilo.
Hi, Stephanie, and thanks for the introduction. Welcome, everyone, also from my side. So it is widely known that AI is steadily growing even after the COVID situation we are living. The IDC predicted that in the next 4 years, AI application will grow by about 70%. But actually, innovation will probably come because of edge computing. Indeed, traditionally, the cloud has provided the computing power to process the data, but actually edge computing can provide computing capacity where actually the data are generated and can be processed. So for example, at the edge server layer, we can process the data, or nowadays, even at the IoT level, the hardware vendor are working a lot. You see also some figure of the growth of edge computing. And actually, the data can be processed also at the IoT level. And in this way, to the cloud, we send just some images, for example, that are pre-processed, so cannot be read by the cloud, even by the cloud provider. However, in this way, the computing continuum infrastructure becomes rather complex. The situation is made difficult because AI is hungry. It actually is hungry from the engineering perspective. Unfortunately, in the market, there is a lack of expertise, and actually there are a plethora of framework. Usually, the machine learning engineers, the AI engineer, want to use in the very last framework. The process of development, unfortunately, is unstructured. So AI models are built with a trial and error process. And actually, it's also well known that deep learning is becoming popular nowadays because it can increase its accuracy while we ingest larger volumes. But processing larger volumes on one side make also the privacy and security of the data of the end users an issue. And moreover, to process large volumes, we have a problem of computing capacity that are provided by nowadays both at the cloud level and the IoT at the silicon level. But unfortunately, as I was mentioning before, the computing continuum infrastructure becomes complex because it is heterogeneous, and we need to trade off optimally the computing capacity provided by the cloud computing and by the IoT side, where we have also issues of costs of use of resources, but also of energy, for example, consumed from the silicon side. So for this reason, actually, another important point is while we are all here because we are interested in AI, we need to consider the fact that if we look at, for example, the big players like Uber, I don't know, Google or Facebook, just to mention a few, the AI code, the machine learning code, is just 5-10% of the code of the full system. So for this reason, in our project, can you please move to the next slide, Matteo? For this reason, our project is going to develop an integrated design time and runtime framework where we will provide some simplified programming models in a way we can shorten the time for development of new AI applications. We will take a kind of DevOps approach, and we will automate also the deployment, and we will implement also some advanced policies and mechanisms which will allow the dynamic reconfiguration of the infrastructure in a way that, I mean, our goal is the maximization of the AI model's accuracy, but on the other side, we rely also to provide some guarantees of performance of the underlying infrastructure in terms of time to process an image or the rate of which the images can be processed in a kind of image processing applications. And moreover, we are also developing some specialized building blocks that have a specific AI flavor, where we will consider, for example, distributed training, privacy preservation, and architecture enhancement. So these are the topic that will be developed more by Matteo. So Matteo, thanks, the floor is yours.
Thank you, Danilo, for introducing me. What I would like to talk to back up on.
Sorry, Matteo, that was my fault. I was supposed to give an introduction. Matteo Mattiucci is an associate professor at the Politecnico di Milano. Among the coordinating team of AI Sprint, his research interests include machine learning, perception, robotics, and autonomous systems that are heavily dependent on edge computing on AI and edge computing. And he will talk about the AI challenges in the context of AI Sprint. Thank you, Matteo.
Thank you, Stephanie. I would like to continue on what Danilo has said by giving you the AI perspective. Danilo has talked about the system and infrastructure perspective. I would like to see the other side because the continuum computing now breaks the traditional AI development paradigms. In the past, there was a sort of separation between IoT collecting the data, training happening either on premises services or on the cloud. And then once the model were trained, these were, let's say, shipped to the edge servers or machines for the inference. Probably the most, let's say, distributed way of dealing with this architecture was to have part of the inference done on the edge devices and part done on the cloud. Nowadays, this is not anymore possible because, as we have seen from Danilo's slide, we have a continuous of AI devices, cloud servers, edge servers, and data moves up and down, processes move up and down, inference happens up and down. And within this context, engineering cannot be an afterthought. So if it was possible, or at least there was the common practice to first develop in a, let's say, isolated manner the AI models and then deploy them on servers, nowadays it is not anymore possible to think engineering and AI development as totally separate tasks. Indeed, we have a real continuum, not only in the computing capacities, but also in the way inference and training can happen. You could have everything on the cloud, and this is what is usually done today. Then you could have some training on the cloud, but the inference is distributed between the cloud, the edge, and the devices. But with the power of modern edge devices or even IoT, we can start thinking about the training happening as close as possible to the data. This is mostly due to two reasons. The first one is to reduce or shorten the path between where the data is acquired and where this data is processed, but also for privacy reasons, because you can cage, you can put in a sandbox your data and be sure that your data do not get out of the device. Now, with this continuum, not only in the computing, but also in the way AI models could be designed, we can see different approaches for training, where you have either a centralized training, where you centralize the data and you do training on the cloud, fully distributed, where you have training happening in devices, and even hybrid approaches. Not to talk about the inference part, where you could have full edge device inference or some mixed inference between edge and device, or even just some cloud inference happening in data center. This is really a complex scenario also for the design of AI models. Indeed, if we think about nowadays neural networks or nowadays complex deep models, no one of them has been thought from the very beginning with this kind of deployment in mind. Indeed, as I said at the very beginning, what really happens is that you develop a model based on your knowledge about the process or based on your data. And once your model has been trained, then you try to fit it on devices. Sometimes you do it at the very end. Sometimes you do some loop in the design to be sure that your model will fit in the target device. But right now, we don't have tools for the design for deployability, for the design of neural network in such a way that you are aware of where they will go. So these are the challenging, but as usual, we see in those challenges interesting opportunities. And these are the opportunities we see as part of AI Sprint project. The first thing is that we can think novel techniques for developing models in an automatic way by leveraging the complexity of deploying environment and try to go beyond AI designer intuition with automated tools. Second, as we have a naturally distributed environment, we could leverage distributed learning models like federated learning and try to move the federated learning approach to a continuum computing system where we can leverage also on edge, let's say, capabilities, edge power, and increase this way data privacy and training. And these are the two core technologies that will be developed from an AI perspective within the AI Sprint project. Okay, thank you for listening, and I will lead the floor to the next speaker.
Yeah, this is Enrique Bartida. He is head of data to results team at Beck et al. His work focuses on cloud, big data projects, and manufacturing. The floor is yours, Enrico. Thank you.
So thank you, Stephanie. So we learned in the previous presentation from Matteo and Danilo that the AI Sprint project will develop a framework for AI-based applications running in the cloud, on the edge, and everywhere in between. But our project has a second goal, and the goal is to prove that the framework really works in real life. And so we selected 3 projects to test the framework. And those projects are interesting in 2 different ways. So first of all, they address very common and very important real life issues. And today it would be very difficult to address those real life issues using technology from Google, Microsoft, or AWS, or very expensive. And so we will prove the efficiency of our tool using those 3 use cases. The first use case is, could you please move to the next slide? The first use case is about personalized healthcare, and it's about stroke risk assessment. Now, the importance of the use case is very easy to see. Today, strokes account for 8% of all deaths in the European Union, and strokes are one of the biggest health concerns in modern society. But on the other hand, we know that 80% of strokes could be prevented. So our goal in this project is to work on this 80% by delivering a real-time, accurate, and individualized risk assessment. Now, from a technical point of view, the solution has two main areas. There will be an edge component with a smartwatch and a smartphone acting as a server, and the second component running in the cloud. And as Matteo explained, the inference will take place somewhere. So part of it on the smartwatch itself, part of it on the smartphone, and part of it in the cloud. And with time, we will develop better and better models. And so the deployment capabilities of AI Sprint will become very important because we will have to update all the models with time. Now, this use case has a very special aspect, which is security. So we are dealing with patient data. So it's the most critical data from a privacy point of view. And we will deal this in different ways. First of all, we will encrypt everything everywhere. So not only data, but also code containers. But also we will use federated training. So instead of moving sensitive data from somewhere to the cloud, we will actually move the AI training process from the cloud to somewhere so that we don't have to move sensitive data. And in this way, we can use the AI Sprint framework to address privacy very efficiently and effectively. The second use case has to do with maintenance of windmills. And here the goal is to reduce costs and especially reduce downtime. Now, windmills maintenance is extremely expensive, and there are different steps involved. We start with collecting data on the field or at sea. Collected data is analyzed, and a report is created, and this report is actually used for planning the actual maintenance. Now, with AI Sprint, we will be able to simplify the process by performing some of the analysis while the data is being collected initially, and our goal is to reduce the number of trips. Now, technically speaking, our sensor will be a drone with a camera. We will have an edge server, which is a PC. And as in the previous example, we will move data from the edge to the cloud. We will, of course, use the power of the cloud to train and improve our models and redeploy them. But also in this case, we don't know right now where we will run the models. Ideally on the drone, but we don't know how much it will be possible there because we have some clear limitations there. So we will use the flexibility of AI Sprint to decide at runtime where inference and which kind of inference will run where. The third use case has to do with farming and to optimize the phytosanitary treatment in vineyards. Our goal there is to increase treatment precision and at the same time reduce the amount of chemicals we use. Now, today treatment is executed on a lot base. So farmers look at a map of their vineyard, and depending on the season, they decide how much chemical would be used and applied in which part of the field, in which lot of the field. With AI Sprint, we will transform the tractors into a smart sensor, and chemicals would be, the quantity of chemicals would be tuned based on foliage volume, foliage shape, humidity, and other factors. So we will be able to be a lot more precise in delivering chemicals in the vineyard. And again, from a technical point of view, we have this edge cloud situation. So our edge is a tractor, and we need to run the inference in the edge. In this case, it's clear that it has to be on the edge because we have a latency issue. But we also know that we will be able to collect data on the edge, process it in the cloud, and with time improve our models. So if we try to put it all together, we see that, if you could please move to the next slide, Matteo. We see those use cases really test all the components of our framework So we will have inference and training in the cloud, on the edge, and on the IoT devices. We will have different type of servers. We will have different type of devices, and we will have also different type of AI models. So we really are convinced if we are successful in those projects, we have proved that we can basically be successful in any AI project where edge and cloud continuum is needed. So thank you.
Thank you very much, gentlemen. That was a really insightful but concise explanation of AI and edge computing combined together. This is a super, I think this is, we looked at also some of the really compelling use cases that we have that demonstrate where AI and edge computing are fundamental to bring together to zoom in. Just a reminder that before we move on to the panel discussion and our first survey, if you have a question, please post it in the Q&A panel and not in the chat, because otherwise it makes it very difficult to follow. But let's start with our first poll, and this is to understand a little bit about how much our audience this morning understand about AI and edge computing. So how would you rank your knowledge of AI and edge computing? It could be both, that you have a very good understanding of both of them. It could only be of AI, which is the second option, only of edge computing, especially if you come from the cloud continuum background, or you have some understanding of both, or some understanding of one or the two, or little understanding. So please be quick. We have 60% of participants who have responded to the poll. Quickly, let's get up to that 100%. Everybody, please, ladies and gentlemen in the audience, you can vote now. Almost there. Bang on time as well. Thank you, gentlemen, for keeping to the time. We're moving on to the discussion panel very soon. Okay, let's launch the results then. Thank you, Rita. So those are the results. So most of you have some understanding of both, but not there's not many people in the audience who actually have an understanding of both of them. So thank you very much. I think we can stop sharing the results now. Thank you very much. And it's my pleasure now to introduce you to the panelists. So joining us this morning, we have a super lineup and a very mixed, very nicely blended, I think, balance of expertise on the topics that we have this morning. So one of the people on board is Domenico Siracusa, who is head of Rising Research Unit at Fondazione Bruno Kessler. He is project manager and technical leader of the Horizon 2020 project Decenter, which brings together Europe with Korea, and they are developing a robust fog computing platform. I think some interesting lessons learned could be shared by Domenico this morning in our discussions. And then it's my pleasure to welcome also Atia Cortes, who is co-director of the AI for EU Observatory on Society and AI. She's an expert in artificial intelligence and ethics, and works at the Barcelona Supercomputing Center. So a big welcome to you, Atia. Then we have Danilo Pai, who is ST Fellow at ST Microelectronics, where his work focuses on developing solutions for deep learning tools and applications. Danilo is also a member of IEEE and looking at and part of the work on there on machine learning, deep learning, and AI. So welcome to you also, Danilo. Then we have, last but certainly not least, Alfonso Progetto, who is CEO and Scientific Director at Jeffriel. Jeffriel is an entity whose goal is to promote and support innovation in companies and public administrations. So a very warm welcome to you this morning. We'd like to kick off and ask each of you on the panel, and of course our super panelists from AI Sprint are welcome to also join in on this. The first question would be, which of the challenges discussed today should we prioritize and why? So how do you see AI and edge computing in the context of AI Sprint? We'll start with our first panelist, Domenico.
Good morning. I hope you can hear me, and thanks for the invitation.
Good morning, loud and clear. Thank you very much.
That's great. So I like to be short. I think that one of the challenges that have been presented and was really interesting to me is related to the federated learning. I think it's a great opportunity for us researchers to propose solutions to ensure privacy when training at the edge. And we try to look at this aspect on the Decenter project, but there is clearly one problem that may be really important for AI Sprint to deal with. It's when you have, for instance, non-identically distributed data sets. And this becomes really a challenge when you have very different sources of data. So I think there is large and a great opportunity for research in this aspect, and privacy for edge training, it's quite important. So that will be one of the aspects I will surely prioritize.
Thank you very much, Domenico. Attia, what would be your position on this point? Where are the challenges of bringing the two together?
I thank you. First, I agree also with what Domenico said, and also I was thinking about the challenge of the infrastructures. I think someone commented on how these assets can be installed in different places and what are the opportunities depending on the field that they are being applied. So it is very important to ensure some interoperability to make sure that these assets are really useful for everyone working on the domain.
Thank you very much, Attia. And also then, Alfonso, welcome. And what would be your main challenges that we need to prioritize?
Well, from the discussion we heard so far, and the experience that we have collected in the past years, it is clear that AI is becoming a critical component of our society. So AI applications are not just, tools for researchers or enthusiastic people. We have now developed very impactful and critical applications that must be managed as such, as products. So the key issue that, in my opinion, has been emerged from the presentation we've seen so far and from the experiences we have collected in the field is that we need to grow an engineering approach to conceiving, developing, and managing complex AI applications. So it is not just a matter of have some clear and innovative idea and transform it into something that can be used by a researcher. We need to understand how, given all the differences and peculiarities of AI system and application, how we can exploit this technology and this approach in an industrial way so that we can really deploy systems that can be used on a wider scale by a large number of users, systems that can be maintained and evolved depending on the needs and requirements and feedback that we collect from the field. So I think that this shift from research-oriented or innovative development of prototypes and system into product deployment and management is a key issue that the community must address in order to really move forward.
Okay, well, thank you very much, Alfonso. And your thoughts on this, Danilo? Here I'm talking to Danilo Powell. We have, yeah, thank you.
Yeah, thanks.
Economics.
Thanks for asking. Certainly, the biggest challenge is to move away from the paradigm of centralized intelligence. And when I say centralized intelligence, I refer to mapping, deployment, even conception into virtually unlimited resource machines. There is a huge context that motivate the need for distributed intelligence. First of all, in terms of IoT, there are 250 billion of microcontrollers deployed, and the expectation in terms of growth are tremendous. In terms of automotive, the same. Just an example, 130 ECUs with microcontrollers can be found in a car. There are a number of limitations, poor scalabilities, slow responsiveness, edge units which are dumped in the centralized paradigm. Energy consumption is huge from the data center. Intrusions, definitely the IoT devices can be intruded, and there is a waste of bandwidth. Just imagine that by monitoring a single motor with a couple of accelerometer biaxial will generate continuously about 27 gigabytes per day. So this is a tremendous waste of resources. The community is also moving in that respect. There is a huge community, which is TinyML, with hundreds of industry and thousands of experts which are interested. So the fundamental technologies I heard today in this project that are aimed are, first of all, understand how to design neural network in order to tune automatically their properties to distribute them between the edge and the cloud. And this is a technology of paramount importance to increase productivity. And the other is the capability to learn at the edge. Now, learning at the edge means reuse very constrained resources. And these challenges are very important for the industry, not speaking about the interoperability. When we have the cloud and the edge speaking each other, these guys have to use the same common language to interoperate.
Yes, in fact, lots of challenges. In fact, some applications like autonomous driving are fundamentally dependent on AI and edge computing, aren't they? There are lots of challenges. So let's move on to our next question. And that is, what difference will cloud computing bring to AI in contexts such as AI Sprint? Clearly, we might want to listen to also Danilo, Professor Danilo Ardegna and his colleagues, and also Enrico on this point. But first of all, I'd like to open the floor to our panelists. What difference will cloud computing play in this scenario? Maybe we could start with, I don't know who wants to start, please.
I can start.
Okay, thank you very much. Domenico?
So what I think is that what cloud computing can do is what they already did in other scenarios. So it's basically transforming technologies into successful services. Basically, cloud computing is nothing new. Technologies were already there even when we started using cloud computing. But it was a different perspective on how to provide services. And this is one of the first and foremost important things. And as of today, many of those applications, so when Danilo, Professor Ardegna, said we are looking into, EI, the method, the model is just a small part of it. That's true. When you want to have an applications that runs over a distributed infrastructure in an automated way, because this is the only way we can go forward, you have to design applications that are cloud native. And this is a very important thing, a very important enabler to be able to distribute intelligence and distribute computational capacity over a distributed infrastructure. It becomes much more complicated when this distributed infrastructure is not just a data center, but it's a cloud-to-edge environment where you have heterogeneous resources. And in this perspective, another thing that what cloud computing, the cloud environment ecosystem did very well was integrating technologies. I think that the integration with the IoT world and IoT systems becomes paramount, because it's not just where do you process the data, but how do you distribute that data directly on the spot where it is necessary. Nowadays, most of the brokers are not really ready to do that, and you should be able to distribute that data and have it on every edge computing node that needs to compute that data. And furthermore, what you could do is also to go ahead of this and say, I'm not only distributing data from sensors, but I'm also distributing intelligence, so outcomes of AI models that are running on some edge nodes and making this available for others. So we need kind of a, let's say, distributed knowledge base across this cloud to edge ecosystem, which is quite relevant. And I think these are the next steps in what cloud computing can provide as a ecosystem and way of thinking to this to context like the ones that you are looking into with AI Sprint.
Thank you very much, Domenico. In fact, yeah, that was an interesting point there, because when we embarked, well, I embarked on the cloud journey, we did notice that the cloud native apps were always the winners. Basically, it was much easier than actually porting an application to the cloud that had been designed for something else. Who would like to go next? Maybe I can, of our panelists. I don't know if Alfonso or the other Danilo, Pao, would like to say something here.
Well, maybe I can add just a comment to what has already been said.
Thank you very much, yes.
And I guess that one of the critical step or element of in these complex settings we are discussing, it will be how we will manage the iteration between testing, deploying, and evolution of AI system, given the distributed nature of the environment in which we are going to run it. So especially when we combine edge computing with cloud, with other kinds of computing elements, well, the fluidity and the consistency of this iteration will be very, very critical. So we need to assess the ability of the system to be useful for our for the end users, for the application we have that has been for which we have designed the system. But then we have to deploy and evolve it. So I think this iteration will be a key element to consider and a very critical problem that we must be ready to address and solve.
Very pertinent point there. I don't know if Danilo or Tia would like to add to these comments.
Yeah, I would like to add also some comments.
Yeah.
One forecast for the last year was that 50 billion of IoT devices were meant to be deployed worldwide. Now, every IoT device has a number of sensors attached, which means that really on the field, we are seeing hundreds of billions of sensors. So in that respect, in that new configuration, the role of the cloud has to be profoundly reconsidered. For example, has to be capable not to centralize the analysis and most detailed analysis, while should aggregate the knowledge and perhaps redistribute, redeploy something that takes in consideration about the single know-how of each single sensor in such a large scale scenario. Coordinate these behaviors, which is another important function. Some decision can be taken locally, but how can we consolidate and how can we aggregate them together in the light of taking decisions? these are the fundamental, let's say, features that the cloud has to consider rather than centralizing everything.
Thank you very much. Anyone else? Atia, would you like to add?
Maybe
Oh,
may
Danilo,
I
yes,
comment?
John.
Yeah, I will
Danilo
follow the
Adagno.
comment.
Yeah.
Yes, thank you. From my point of view, I agree with Danilo Pau, of course. And actually, what I think the cloud can provide is, on one side, flexibility and capacity, right? So what we're envisioning in the project is also the fact that it's true that the processing will happen at the IoT level, at the edge layer, but actually this might become a bottleneck. So what we're envisioning is, for example, that whenever the edge is saturated because of limited resources, the cloud will help actually by moving some computation from the edge to the cloud. Of course, there are a lot of trade-offs. There are the need also from the network, but also 5G is developing, for example. So, I mean, we also in some scenarios, the latency can be reduced also because of the network will improve in this incoming year. And moreover, what the cloud can provide is the centralized view. It's true that we will aggregate the knowledge from the IoT, but if you have a different IoT domains, for example, what we can do at the cloud side, we can have the centralized view that is, while vice versa, the edge has still a limited distributed view. So that's where probably some more intelligence can be generated because of the centralized view, what is happening at a full system level.
Yeah, exactly. Yeah, we'll see more developments, I guess, with 5G and technologies like predictive quality of service as well. We're bringing in. We know that the automotive sector has been one of the areas where a lot of trials have taken place internationally. So not just in Europe, but also in the USA and also in China. So these could be some early lessons learned, I guess, from this. We'll go on to our next question. We do also have, gentlemen, panelists. We have some questions also in the Q&A. We do remind the audience that this is the place to post your questions, not in the chat, please, because otherwise they will get lost and we won't be able to answer them. But let's go on to another question that we do know that is interesting. And Danilo, Professor Denia, touched upon this at the beginning of this webinar, the cloud computing market. But my question would be, considering also a lot of new research and development on AI and edge computing in Europe and elsewhere, AI Sprint is just one example of this. How do you see the landscape evolving in the 2021-2023 timeframe, or even up to 2025, when we expect, for example, 5G networks to be widely deployed? So that would be my question to the panelists now. Don't know who wants to volunteer to go first.
Maybe me. Definitely.
Hello?
One of the most importantly design networks and deploy them considering since the beginning constraints in terms of deployment. So I refer to neural architecture search and hyperparameter optimization that Matteo was mentioning at the beginning. These are very important. Why? Because this is tightly linked with another point that Matteo raised. We should not consider separated the AI community from the embedded developer community. That was the mistake. That was the error that discouraged the huge investment by the community on artificial intelligence. And today, designing neural networks, machine learning appear like writing assembly code in the ancient days. So this has to be solved, because after all, what we aim is to increase the productivity of the developers. Just consider an example. We serve for the microcontroller on IoT 40,000 customers. Imagine the poor developers that are left alone without any productivity tools. The TinyML community with hundreds of industry supporting the initiative are also looking about that. So a jump in technology that allows this advancement will bridge fundamental needs of the developers and solve lots of problems that we have today.
An excellent point. Thank you very much. I will invite my panelists also this morning to have a quick look in the Q&A. We have lots of questions. Is there one in particular that any of you would like to answer? We're doing pretty okay for time. We've got a couple of minutes. So if all of the panelists, if you'd like to choose also a question from the Q&A panel that you think is important to answer this morning. None of your questions will be lost, by the way, gentlemen and ladies in the audience. But if there is one that our panelists would like to pick on and answer.
Yes, there is a question that I like very much.
Thank you very much, Enrique.
So 80% of data processing is expected to move from the edge in the next 5 years. So we are looking at 3 applications, but there are many more. And I think that's a very, very good point. So on the one hand, the 3 applications we look at are, I think, very diverse and cover a lot of different business cases, but there are many more out there which we cannot cover realistically within this project. I believe the real impact of, or one of the most important impacts of AI Sprint is to provide an open source tool set for solving those problems. And if I look from my role, Beketal is not a research institution, so we are an IT company. So our job is to make money with our customers. And if I look at the issues our customers have, is that there is an increasing complexity in the cloud. And in the past few years, there are tools that allow or simplify a little bit cloud orchestration. But if we move into the AI, we will end up having the same problem. So there is a lot of complexity. And we know that companies like Google, AWS, Microsoft will address those issues, but they will also use those issues to lock us and our customers to their technology. And I think the AI Sprint is very important, is the ecosystem, because it will address a variety of issues, but it's really agnostic in terms of cloud. So we really don't care what's underneath. We just want to allow developers to solve their AI problems and independently from the underlying infrastructure provider. So I think this is really important what we are doing, and I expect in the next few years other projects, other companies to come up with similar solutions, and I expect and hope there will be an ecosystem of tools that will allow, let's say, AI orchestration in the continuum. And I hope and I think that AI Sprint will be an important player in this ecosystem.
That's a really nice point that you raised there. Anyone else would like to comment on this?
If I may touch for a second to this last comment from Enrico. Yes. I think, I mean, the part, so the biggest deal with AI and edge computing at the moment is adoption. Many companies still, I mean, I'm talking, for instance, a little bit of the Italian market, but many companies still haven't embraced anything with respect to a cloud native approach and edge computing, where those combines. So the first and foremost important thing is about to go towards adoption from companies, and this is like something that also European projects can spur by presenting advancements and outcomes and benefits of those technologies. Their orchestration will become very, very much important. As soon as many companies will start to embrace those models, orchestration of services and AI containers will become paramount to ensure that resources are wisely used. So I wanted just to touch to the previous comment. Orchestration will become a very important thing in the next future. The regarding the questions, I've answered one related to the NVIDIA Javier or TX2, let's say cards. So that answer can be found written. I wanted to look. There was one interesting question from Vissam Maluli. Sorry if I mispronounce it. Like how can you preserve privacy at the edge? Do we trust edge devices? This is really important because even if you do federated learning, some data will come directly at the edge device. So then, okay, you don't send important data to the cloud, but can you trust edge devices? This is an interesting question to me. There are two ways I will, sketch and answer it, but that's the first one is, okay, of course, this depends on the architecture. Who's owning and who's managing the edge device, it's important. If it is the customer that manages most of the edge device, but then there is a microservice run on that edge device that does the, let's say, part of the federated learning process, that may be in a case in which you can trust that device. But there are also other solutions that, for instance, in which you can see enclaves or other solutions where you can try to have a trusted environment within your node, within your edge node, to run your, let's say, sensitive processes. This could be also kind of a solution, which you may think of. But there is plenty of research that can be done on that aspect. So I hope this kind of answers to that question.
Yeah, thank you very much, and thank you, Vissam, for your question as always. Very pertinent, indeed. Okay, so let's just we could go on talking for the whole day, perhaps even longer than that. But I'd like now to pass the floor to my colleague Nicola Zapteri, who will give us a little overview of the AI Sprint Alliance. This is a super opportunity. So the floor is yours, Nicola.
Yeah, thanks, Steph, and
Thank you.
Thanks everyone for attending this webinar. So we heard about some challenges in AI and edge computing, how AI Sprint is going to tackle that in a very practical way. So here's how. Just wanted to briefly highlight the opportunity that you might have by joining one of the main outputs of the AI Sprint project, which is going to be the AI Sprint Alliance. So the Alliance is basically targeting three main, let's say, end user. So software developers, system integrators, and cloud providers. Each three of these, let's call it stakeholders, could play a different role inside of the Alliance. So the main aim of the Alliance is to basically use the AI Sprint design tool and runtime environment to help organization to design solutions which are hosted in a platform and extend basically the management and the efficiency of their resource to work more efficiently. So we are currently setting up this. So the timeline that we are envisioning is starting from June 2021. The Alliance will be set up as an, let's say, a dedicated online space in which all the organizations that want to join can basically have a dedicated communication channel, but also repository space and collaborative tools to exchange vision, have meeting together, so to share insights, technological and business innovation, and basically benefit from the synergy that we will try to develop. So how can you join this? So as of the moment, you can sign up a letter of support that we will be glad to send you. Just be in contact with me. I put my email there, or with Danilo Ardagna, so the coordinator of the project. So you can find our contacts there, and if you are willing to join, or you would like to have more information, just drop us an email and we will be right back to you. If I may, I also wanted to to remind that we have a website, aisprintproject.eu. So please go on there and be sure to subscribe to our newsletter and follow us through our social media so you can stay up to date on the progress of the project and the alliance itself.
Yeah, if we could just go back to the Q&A chat. Thank you so much, everybody, for posting in so many really interesting questions this morning. We do have, I believe Atia would like to also respond to the question posed by Vissam about the trusting in edge devising.
Yeah, I was typing the answer.
Thank you. Yes, thank you.
Do you prefer I type it or?
No, you can answer it live. We've got 2 minutes. Okay, thank you.
I just wanted to add on top of what Domenico said that so privacy is obviously very important, but it's also true that we have some mechanism to show that we are being compliant with different regulations. But in order to ensure trust, we need to also work on different aspects in order to show this general accountability. So, for example, making sure that all this infrastructure, all these assets are being accessible for different people. So, for example, giving the same opportunities to SMEs than to big companies. It's also important to be transparent. And it's also, I think, very important, and we didn't mention it today, to think about not only the social impact, but also the environmental impact of using cloud systems. So I think we should move towards this kind of, let's say, green thinking in which we are aware of the amount of data that we are using. So we are trying to move to this data minimization that in the GDPR is recommended, but also in the way that we are training our models in order to be conscious about the resources that we are consuming every time that we are using these big data sets and these cloud systems. And that's it.
Yeah, that's a super point. Yeah, very important. Thank you. Yeah. I think that's really a wrap up. I don't know if there were any last other points that we want to have a quick round of key takeaways from our panelists and speakers this morning. I could give you like 30 seconds each, starting with Danilo Ardegna, go in order of the agenda. A lasting message for our audience, yeah.
Yeah, so I mean, on my side, I would like to thank everyone who connected. We don't have the time to go through all the Q&A that we actually received, but if you leave, I mean, your contact, we will back to you, and I really hope that you will join our alliance and to provide feedback on the research we are developing. So, I mean, I would like just to limit to thanks the people. Stephanie, we can move to the next speaker.
Lovely, yeah, thank you. Matteo?
Yes, thank you. I would thank all the participants also for their interesting insights. I see that the privacy and trustworthiness of the development of AI tools on the cloud has raised a lot of question, concern. I will just want to point out here that we are fully aware of this. Indeed, the project has a full work package dealing with privacy and security from the very beginning, so it's not an afterthought, as you clearly suggested. So yes, thank you for pointing out. This was the first webinar. The project just started. Just keep up with us and we will update you about the news of the project. Thank you very much.
Yeah, thank you as well. Yeah, Enrico?
Sorry, yes, thank you also from my side. I was muted. Thank you for moderating this, and of course we will keep everybody posted about this information and what's going on in the development.
Yes, in
Thanks
fact,
a lot.
our key call to action is to please log on to our website and follow us also on our social media. I don't know if the other panelists would like to add anything to this, like a lasting takeaway. For example, Atia or I think we've only got Atia or Domenico. If you'd like to say one final thought, share one final thought for the day.
Well, nothing in particular besides thanking you for inviting me. We look forward to hear more about the project and collaborate with you, since we are in the last steps of the other project. And keep in touch with us if any of. I hope my contact will be shared with the attendees. So if they want to ask something about what I said, they didn't get the time. But that was really interesting. I think that there are a few challenges addressed by AI Sprint that are really interesting to know about more in the next future.
Yeah, absolutely. Thank you very much, Domenico, for joining us. We've got so much to talk about, haven't we? Clearly. And I don't know if Tia, you'd like to leave one final comment. We are just a couple of minutes over time, but the audience is still with us, so please go ahead.
No, very quickly, I think it was very interesting to learn about this project. I think there are many opportunities here. Also in AI for EU, we are trying to build this kind of place to share this kind of assets and make them more available to more people. I think this is a very important point about reusability of the resources, and I expect to see more about that in the future. Thank you for the invitation.
Yeah. Thank you. Before we leave, we'd just like to ask the audience to have a really quick, we've got one final poll just to understand where you sit in the landscape around AI and edge computing. Rita, if you could just please launch the poll. It's a pretty quick question. So basically we want to understand where you sit in the landscape. So please just complete this sentence as it applies to your organization, be that a research institute or a private company or a public sector company. So we can have a little bit of an understanding of how we can position our participants this morning. Give you another, we are just not quite 5 minutes over time, but I think it's 5 minutes well worth listening to. So yeah, I'll give you another. We're on, over 60% of the participants have voted. Let's see if we can get that up to 80%. But I do really would like, as I said before, we could talk and talk and talk about this for many hours, and we will be doing that. So please keep in touch with us and stay tuned for more webinars and some podcasts as well that we're planning in the coming months. And hopefully before the end of AI Sprint, we will be able to meet also face-to-face as soon as that's safe enough to do so. Thank you for all the very positive comments also coming from the audience. And also thanks for all of those great questions that you've been asking this morning. I think that's a testimony to the big interest that we have in what we're trying to tackle in an AI Sprint. So yes, so most people in the audience, as we have at the moment, are conducting research on AI and edge computing. So there we go. That's an opportunity also to cooperate with us. We do have an activity that is destined to that very thing. So please get in touch with us through our list, our email on the website, or we will share in the follow-up email also some contact details that you can use, because we'd very much welcome a lot of collaboration on what we're doing. We're looking also not just at what we're doing technically, but looking also at what's happening in open source and standardization. So with that, let me just say a massive thank you to all our panelists and speakers this morning, and also to our participants. Thank you very much. Please stay tuned. We will be sharing all of the recording and the presentations and as many of the questions that we can answer that you've posted on the Q&A chat in a week's time, because we've got this holiday period. So I wish you all, those of you who are taking that holiday break, also a relaxing long weekend ahead. Thank you very much. Thank you very much, gentlemen and ladies. It's been lovely talking to you this morning. Thank you for your insights.